here, but I will let you know that we are going to continue with Chapter 3, and Chapter 3, we only have 2 sections, but Chapter 3 has a lot of properties to know and understand. When you do some of the questions, you are going to be asked about properties. You're going to need to make sure that you know all of the properties so that you can select all of the choices that go with it. Sometimes they may have slightly different wording that I do, but I will give you credit. With that said, let us begin. We have already talked about parallelograms. That was all of section 3.1. We began last Wednesday with rhombuses, and we went through the properties that deal with rhombuses. Well, now we're going to talk about rectangles, and rectangles have several properties, but I wanted to break them up so that instead of putting all 6 on one slide, I can kind of explain them a little better as we go through. Now, to begin with, a rectangle, the most important thing you need to know is that it's got right angles. So that means all of these corners have to be 90 degrees. But you need to recognize that in a rectangle, they only have to give you one box. That box then says the figure is a rectangle. Okay. Then, if we look at number 1, that should make pretty good sense because the same thing happens with parallelograms. Opposite sides are equal. So my red sides and my green sides are going to be equal. And notice, the opposite sides are equal, but I have a box. That's what distinguishes this from a parallelogram, because a parallelogram, opposite sides are still equal. But the fact that I put that little box took it from parallelogram to rectangle. So these are 2 properties. Now, the third and fourth property, well, again, I'm going to make sure that you see that this has a box. I'll put the box up here. But it's saying alternate interior. The reason is a rectangle is also in the parallelogram family, which means that even though these 2 sides that have one blue arrow are said to be congruent, they are also said to be parallel, which means that these 2 sides that I've got red arrows, they are also parallelograms, but the fact that I have a box gives me the rectangle. But notice what happens here. Alternate interior, which means this angle and this angle are equal. You will also have sometimes a second diagonal, which I'm putting in black. And this will give me alternate interior. Okay. And I'm going to put one orange, and I'm going to do two greens here, two greens here. Alternate interior angles are equal. We're also back to consecutive, but that makes sense. This angle and this box have got to be supplementary. But also, the blue box and this box has to be supplementary. And don't forget, all of the angles are 90. All. Now, based upon these first four rules, are there any questions? Okay. Now, this is a fifth property, and this property deals with diagonals. Now, this again has a box. Okay, that's what distinguishes it from a parallelogram. But the difference here is the black diagonal, and I'm going to give this letters. The black diagonal, which is AC, is going to equal the blue diagonal. They are equal. But just like a parallelogram, both diagonals bisect each other. Now, here's the funny part. Because both are equal to each other, this half and this half, this half and this half are all equal. They bisect each other. So that means if I put this letter as E, A to E equals B to E, which equals C to E, which equals D to E. The diagonals bisect each other, but they're also equal. Now, this last property, like any quadrilateral family that has right triangles, you are going to have to be aware that the Pythagorean theorem can be hidden in these problems. Now, I want to show you something. Okay. 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 Now, this rectangle, this is the part that people don't really understand. We have four large right triangles. Okay. And I was hoping to try and copy this picture, but I'm having a little trouble here. So how about if I do it this way? I'm going to add another picture here. Okay. Okay. This is the part that people don't truly understand. Okay. Here's my black diagonal. Now, right here, this is going to give me one large right triangle. I also have a second right triangle here. But because I have right angles in the corners, okay, I should have had more figures here, and I can't. Okay. This blue line, oops, gotta close this. This blue line has a right angle up here, a right angle down here, meaning I have a right triangle up here, a right triangle down here. Notice I have 1, 2, 3, 4 large right triangles. But here's the little catch. I have 4 smaller right triangles. And you're going to say, well, what do I mean? Well, first off, just like the rhombus, I am going to have right triangles inside. This side and this side. This side, this side. What's happening is I have 4 smaller right triangles inside, which makes this 5, makes this 6, makes this 7, makes this 8. I have 8 right triangles all together. But there's one little catch about these ones, and I'm going to kind of highlight it. I'm using this green number 5 triangle because the diagonals bisect the corner angles. If the corner angles are 90 and my diagonals bisect, I happen to have 4 isosceles right triangles inside. It's just the way it works. Because from one corner to the other, I am going to have triangles. Okay? Now, occasionally, depending on the lengths of the diagonals or the lengths of the sides, sometimes they're not isosceles. They are just regular right triangles. But you have to realize that I have 8 right triangles inside here. Okay. Now, 5, 6, 7, and 8 can be definitely isosceles right triangles. Okay. Because the base angles have got to be the same. Plus the diagonals bisect each other. Okay. which means triangles 1, 2, 3, and 4 are isosceles right triangles. Lots of triangles everywhere. But the fact is, they're right. A squared plus B squared equals C squared. Now, let's put all of these properties together. Okay, now, something that my PowerPoint here doesn't have is that it's got a box right here. Okay. Now, one other thing you need to know about properties of a rectangle. This says MQ, which means this side is 6. This side here must be 6. This side is 8, which means this side is 8. Now, you want MQ and MP? Well, notice that is the diagonals. Using just this yellow triangle that I'm highlighting, I have A squared plus B squared is equal to C squared. And remember, simplified root. Now, a root can be a whole number, but you cannot give me a decimal. And some of you, in doing your homework for 2-7, tried to give me a decimal. Decimals won't work. Okay? Mom is going to tell you it's wrong. Okay? So in this case, it's 6 squared plus 8 squared is equal to C squared. 36 plus 64 is C squared. Well, the nice part about it is 36 and 64 is 100 equals C squared. When I take the root, this is 10 and this is 10. Pythagorean theorem. Now, something Mom does that I need to also let you know is that sometimes they give you one box and then they give you 6 and 8. That should tell you right away it's a rectangle, whether it says in the instructions or not. You have a right angle, 2 sides are not the same. Rectangle. Okay. Now, any questions so far? Okay, your turn. In the chat room. Oh, let's see here. Wonderful, Joseph. Okay. In the chat room. What is MQ and NP? Can you figure them out? What is MQ and NP? Hey, some of you are real good. Yes. Everybody should have a wonderful time with their homework. I can tell. Yes, the answer is 8. Yes, you are so good. Okay. It is 8. It is 8. Now, someone asked me why it's 8. Well, for that person who's asking, QP is this side. MP is the diagonal. This has got a box, which means that this side is 17. This is 15 squared plus MQ squared is equal to 17 squared. 225 plus MQ squared is 289. MQ squared is 64. And taking the root gives me 8. Okay. Okay. Any questions with that one? Okay. Now, I'm giving you this for a purpose. The purpose is the fact that right here, AC, it's not drawn. It's not shown in the figure, which means you have to draw that blue line. And this is 5. This is 12. Now, some of this we can automatically get. CD is 5. AD is 12. And it's 5 squared plus 12 squared is equal to AC squared. 25 plus 144 is 169. Now take the square root. AC is 13. Any questions with this? Okay. Now, let's see if you can tell me now, first off, how do I know it's a rectangle? Right here, right here, right here, right here. Can you tell me what X and Y are? Oh, Chris, you're so good. Well, Adam, you got one of them. What's the other one, Adam? Yes, Adam. Yay! Okay. Now, this was a perfect example that I do not have isosceles triangles in this one. First off, I do not have two diagonals. Because I only have one, and one of the base angles is 30, I will know that X is 30, Y is 60. I am looking at only those two triangles, the two big ones. Now, do I have to have isosceles in them? No. Can I? Yes. But in this case, I only have the 30 and the 60. Okay. Now, this one. Okay. Now, this one should be real easy. First off, I have a box. Opposite sides have got to be equal. But this diagonal is bisected, so X is 5. They've got to be the same. This side and this side are the same. Now, why do I need that? Because I want to know why. And y is also, in this case, 5. Diagonals bisect each other. Huh? Oh. Any questions? Okay. Now, some of you love algebra, I can tell. This is asking you for X. Now, I didn't give you a box, which is really right here, because some reason some of the boxes with these rectangles did not come through. So right away, I know AC, which is this side, and BD, which is this side, have got to be equal. That is the properties of a rectangle. AC is equal to BD. This is the geometry. Now, what I have to do to find X is algebra. This is 3X is equal to 4X minus 1. Now, I don't like fractions. So that means every term is being multiplied by X. Why is it multiplied by X? This X and my denominator will go away. This will give me 4X squared minus X. Now, 4X squared minus X minus 3 is part of my wonderful problem. Now, because it's part of my wonderful problem, I've got to factor this. Now, this factors into 4x plus 3, 4x, or it should be just x. This should be x minus 1. If I FOIL it, it will give me 4x minus x minus 3. Now, be careful. I want x. Now, this is a geometric figure. Okay. So, in this case, this answer would give me a negative 3/4. I can't use that answer. So my answer is x is equal to 1. Can't have a negative number in geometry. Any question with this? Yay! Yes, what I did to fractions, Alan, I can do on any equation that has a fraction. It works every time, all the time. Why keep the fractions? Get rid of them. Makes your life easy. Any other questions? Okay. Now, here comes the square. Okay, now, something I need to let you know about a square. Symbol-wise, to tell you all sides are the same. Remember, because a rhombus, all sides are the same. In a square, I will still have the hash marks. But what makes this a square, not a rhombus, is a right angle. If this were a rhombus, the sides are going to be all the same, because in a rhombus, it's a tilted square. So all the sides are the same. But what makes the square is all sides are the same. In a rectangle, opposite sides are the same. But here, all 4 angles. Okay. And don't forget, opposite sides are still parallel. Okay. Some of what we do with a parallelogram apply to other 4-sided figures. We just have to make sure what makes the square unique. Now, the square, okay, all of the diagonals are congruent. That means this red and this blue are equal. Now, this is a definite, like the rhombus. This has got all right angles. But this one is always 4 isosceles right triangles inside, but it's also 4 large isosceles triangles in this figure as well. But the square is totally unique because it confirms all 4 inside triangles are isosceles. Now, can it happen with a rectangle? Yes, but not as often. Can it? Yes. Now, it also brings in the concept of area. Squares, when we go for area, happens to be square units. Okay. Now, right away, how do I know this is a square? Look right here. Yes, Christopher, all of the lines to the center are equal, just like the rectangles. The diagonals are equal. Okay. Okay. Now, some people say this is a little trouble. Well, it can't be. This diagonal is bisecting the angle. So y is 45 degrees. But also, x is 45 degrees. And don't forget, z is 90 degrees. If I know what the figure is, and also notice right here, 6, 6, 6, 6, and I have the box. Life's nice. Okay. And again, if you have to find AC or BD, Pythagorean theorem. Okay. Anything that has a right angle, be aware, Pythagorean theorem. Now, that is basically most of the square. But this is the big one. The trapezoid. Okay. Now, something I need to let you know about. There are 3 types of trapezoids. One is called the general trapezoid. Another one is called a right trapezoid. And my last one is called a isosceles trapezoid. There are 3 types of trapezoids. And we are going to begin with the general. Now, the general trapezoid has one set of parallel lines. This base, which we're going to call the top base, is parallel to the bottom base. Okay? The top and the bottom are always parallel. So you have only one set of parallel sides. Unlike all of the other quadrilaterals in this chapter, two sides are parallel. This makes a trapezoid unique. One set of trapezoid, one set of parallel lines. Now, that top base and bottom base, they're known as bases. Okay. But we also have something called legs. Legs are what connect the top and the bottom base. They connect the top and the bottom base. Okay. Now, angle J and angle K, which are, let's see, somebody said make a different color. Okay. Angle J and angle K are known as base angles for the base or segment JK. We also have H and L are also a pair of base angles, but these are for the top base. This is for the bottom base. JK is the bottom. HL is the top base. Because we have two bases, sometimes they're going to refer to top base and bottom base. Now, any questions so far with the general trapezoid? Okay. Okay. Now, this is our second type. Our second type is called a right trapezoid. Look at right here. I have a box. But notice this and this. One set of parallel lines. Okay. One set of parallel lines. Now, okay. You are going to need to know how this right trapezoid is created. It is created using either a square and or a square or a rectangle with one right triangle attached to it. Okay. This is something you're going to have to get used to. Right here. You're going to need to know how this right trapezoid is created. And you're going to say, well, why do I need to know that? Well, as we go forward, you are going to have to find lengths. You are going to have to know that here is going to be, where I'm highlighting in yellow, is either going to be a square or a rectangle. And I'm going to draw a line from X to P. This black area is my right triangle. The right trapezoid is created. Now, what's in yellow can be a square. It can be a rectangle. We don't know that yet. But we do know that one right triangle is attached. Now, I have the right triangle on the right side of the yellow box. Could it be on the left side? Yes. But the key is the middle piece, the yellow piece, is either a rectangle or a square. When we figure it out, we'll let you know. And then we have the right triangle. That line X to P, you've got to draw. And because we have a right triangle, don't forget the Pythagorean theorem. Anytime you have a right triangle, Pythagorean theorem comes into play. Okay, and you're going to see this as we go forward. Okay. Okay. No, Chris, okay. In a regular, or what we call a general trapezoid, you only have one set of parallel lines. Only one. And those parallel lines are the top base and the bottom base. Because you have to remember, this Z goes all the way to Y. Nope, you're right. I'm glad you checked in. Okay. Now, this is the second trapezoid. Okay. Here is your third. Okay. First off, this base and this base are parallel. Notice, Christopher, only those two bases, R to S, V to T. But there's one little catch with this one. The diagonals are equal. These little side pieces here, these are equal in an isosceles trapezoid. But also in an isosceles trapezoid, okay, this base and this base angle will be the same. Angle V is going to equal angle T, but also angle R and angle S are going to be equal. Okay. Now notice this is unlike a parallelogram, a rectangle, a square, a rhombus. Those other figures, opposite angles are equal. Here, Here, the base angles are equal to each other. The top base angles are equal to each other. And the diagonals within, and the key is isosceles trapezoid, are equal. But they do not bisect each other. They do not bisect each other. Now, I'm going to throw a slide in here. Okay. Now, let's go back here. Okay. In an isosceles trapezoid, okay, you have the top base angles equal to each other and the bottom base angles equal to each other. Okay, that is understood to be for an isosceles triangle, a trapezoid. The base angles are equal to each other, not opposite angles, base angles. But there's one other little catch. How is an isosceles trapezoid created? It is created with a square or a rectangle between two right triangles. Okay. How is it created? A square and a rectangle, but this time it's between. And let me show you what I mean. Okay. This is known as an isosceles trapezoid. Okay. Okay. Inside here, between these two orange or red lines, this is my square or rectangle. But this blue part and this blue part are the two right triangles between it. Okay. They are the two right triangles between it. Now, because this is isosceles, this triangle number 1 and this triangle number 2 will be the same as far as length and width and height. But in the general trapezoid, I still can have a square or a rectangle inside, but my two triangles, my two right triangles, are not going to be the same. Okay. Now, with that said, I'm also going to confirm the angles are supplementary. H and J. Angle H plus angle J is 180. Angle L plus angle K has got to be 180. But H and K are not the same value. Opposite angles. This is the only quadrilateral where opposite angles are not equal. Okay. Now, each pair of angles is formed when parallel lines are cut by a transversal. Now, what they're saying is, this is my parallel line, this is my parallel line. This is one transversal. That's why H and J can be the same. They add to 180. Now, L and K are going to add to 180. But this is a general trapezoid. Okay, isosceles, H and L will be equal. J and K will be equal. But this is for a general trapezoid. Okay, now, the last thing that we're going to talk about is right here. It's called median. Now, we talked about in chapter 2 the median of a triangle. That's totally different. It is a different formula. When you have a trapezoid, be it a general, a right, or an isosceles trapezoid, you have this formula. The median is 1/2 the top base, which is HL, plus JK, the bottom base. Okay, and notice the median is not the same as the median of a triangle. So don't get these two formulas mixed up. Now, I'm going to put and drop down a few minutes or a few places to using this formula. Okay. Now, the median of a trapezoid. Okay. Now, this is where you have to be careful. The median is the H. It is this line. Now, I'd like you to also look at something. Look at the markings on the right side. Look at the markings on the left side. That H, the median, goes from midpoint of one side to the midpoint of the other side. Midpoint to midpoint. So if you see markings like I have here, the two red and the two blue, the H is automatically known as the median of a trapezoid, which means H is equal to 1/2 7 plus 14. Now remember, order of operations, we're going to do the parentheses first, which is 21, okay, which is 21 divided by 2, or 10 and 1/2. That is my median. And something to look at. This is 7. This is 14. This number better be between 7 and 14. Does it have to be exactly equal? No. Because of this formula. Can it be exactly equal? Yep. Okay. But that's the median. Now I'm going to try this one. Okay. Again, notice the symbols. But this time, our median is given to us, which means this is 8.2 is equal to 1/2 6 plus side j. Now, Christopher, this is what I'm going to show you. You see this fraction? If I multiply this side by 2 and this side by 2, I'm going to get rid of the fraction. 6 plus j is equal to 17.4. J has got to be 9.4, and it's centimeters. Do you see how I multiplied both sides by 2? I multiplied both terms. The 1/2 with the parentheses next to it is a term. Okay. 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 It's your turn in the chat room. Okay, this one's got a lot of stuff. But this also shows you, do you know some of the properties of a trapezoid? Okay. What's D? What's G? What's F? Can you tell me what is G? Oh, Christopher, you may be right. Thank you, Chris. Thank you, John. You got me. I love it. Thank you, thank you, thank you. 16, 8. Oh, yep. Or no, it's 10. I can't even add today. Thank you, thank you, thank you. Thank you, John. You're terrific. Without you, I'm in trouble. Okay. Okay. What's D, G, F? You got to know the properties of a parallelogram. Perfect, Hafsa. D is 49. You are correct. Okay, Hafsa, F is not 51, but F is 131. And G, very good, Bridget, it's 73. This angle and this angle have to add to 180. Yay! Okay. 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 Now, I've still got some more to do with trapezoids, but I'm going to stop right here. And I'm going to let you know that we are going to start 4.1 on Wednesday. Now, 4.1 is a lot of algebra that you may not have done in the past, but it's also algebra to help you for 482, because you're going to see what we're going to be doing for section 4.1 in 482. They get you a chance to start here. Now, with that said, I'm going to let everybody go. I will finish up tomorrow.